This video is on EZ terminology and the Cahn Ingold Prelog sequence rules for priority. So let's start by naming this structure and this structure. You may pause now. And yes, it becomes very difficult to use cis-trans terminology when there are more than two substituents. We can refer to the relative terms of, say, the methyl is trans to the fluoro, but it becomes very difficult to put that in the name itself. We don't know what group we would be referencing to if we called it trans 1-chloro 2-fluoroprop 1-ene. So we need rules to determine the priority of these functional groups. And thankfully, some German scientists way back when figured it out. If there are two high priority groups on the same side, we would state that the configuration of the double bond is Z. Z for Zusammen, which in German means together. If you need a tip, it's Zame Zide for the two groups. It's Z. Whilst if the two high priority groups are on opposite sides, the configuration is designated E. E for Entgegen, which means opposite in German. Now I know what you're all wondering. What the hell is priority? How do we know what is high priority and low priority? Well, that's where the Cahn Ingold Prelog sequence rules come in. The Cahn Ingold Prelog sequence rules of priority are a very effective way of figuring out the priority of something when bonded to a stereocenter. They are a simple set of rules that, when used correctly, will always give you the sequence of priority. Rule number 1 states that the atom directly attached to the stereocenter with higher atomic number has higher priority. So for example, in this case, the carbon has higher priority than the hydrogen, and the chlorine has higher priority than the fluorine, indicating that both high priority species are on one side. Therefore, the configuration is Z. Note that as we are talking about atomic numbers, this means that hydrogen is always going to be the lowest. Rule number 2 states that if both atoms have the same atomic number, you have to compare the atoms attached to these atoms. The decision is made at the first point of difference. So for example, in this structure, we'll notice that on both sides of the alkenes, we only have carbons bonded to the stereocenter. So we need to move further away, so the next atom along, and compare those. Once we have a difference in atomic numbers, we assign priorities according to those differences. So in this case, carbon has higher priority than hydrogen, and over here, oxygen has higher priority than carbon, making the structure E. Rule 3 states that double and triple bonds on side chains are treated as though they had that many single bonds to the corresponding atom. This one is easier to show rather than explain with lots of words. So as we can see here, on the left hand side, initially we have two carbons, so we gotta move along. The top one has a double bond, so that means that there are two carbons and a hydrogen bonded to that carbon. Also on the bottom one, we have a triple bond, implying we have 3 carbons bonded to that carbon. Meaning that the point of difference, in this case, is that the bottom one has 3 carbons bonded to the first carbon, whilst the top one only has 2 carbons and a hydrogen. Carbon has a higher atomic number than hydrogen, so the bottom one is going to have higher priority. Now you try with the right hand side. You may pause now, and I'll talk it through it. So first off, we have 2 carbons bonded to the stereocenter. So we look at what's bonded to the carbon. The top one has a double bond to an oxygen and a carbon, whilst the bottom one has a single bond to oxygen. So we are assuming that the top one has 2 oxygens bonded to it, whilst the bottom one only has 1 oxygen. In and therefore the top one has higher priority. So overall, this molecule must be E. I would like to point out that it is not necessarily the number of bonds, it is still the atomic number. So a triple bond to carbon is still going to be less than a single bond to oxygen when it comes to priority. So time to practice. What is the name of this molecule, and include the stereochemistry. You may pause now, and here is the answer.